Hello everyone and welcome back to CSE interview prep. So today we are going to discuss a problem based on the topic array named as next greater element in an array. We have to return in the form of the hash map. Also the brute force technique of the same problem we have already discussed where we have solved this problem in the order of n square time complexity. So here we are going to see how we are going to optimize our approach. So firstly we are going to discuss what the problem is in a quick short. So we have provided this array and we have to return a map of the elements and the next greater elements of all the elements in the array. So for those elements where the next greater element does not exist, we have to return null. So we can see here for each and every element here, like 18 does not have any next greater element, any of the element which is greater than 18 here. So you can see if it is 1, so the next greater element for 1 is 2. So we have just put into our hash map 1 and 2. 3 is having 14 and 14 does not having any next greater element. In the same way 5 does not have any next greater element. So how we are going to solve using the optimized time? So we have to use stack for it. So let's see how we are going to deal with it. So the logic is pretty simple. We have to create a stack and a hash map. Hash map is required to return the overall result. So our method signature is been given in the form of. Now this is what the method signature has been provided to us, NGE, next greater element. So here we have to create stack and the map. Map is for persisting the element and next greater element, and for what reason the stack is used here we will see. So you can see we have to iterate our every element in the array and we will check whether the stack is empty or not firstly. So if the stack is empty, we have to push the element in the stack which is 0th element which is 18. I have pushed into the stack. Now we have to check in the two conditions, whether the element in the array is less than the element present in the stack, we have to push it. Otherwise, if the element in the stack is less than the element in the array, we have to pop it. So the words quite sounds confusing. So let's see the approach directly. So we can see here this element is less than the top of the stack. We have to push it into the stack. Why we are pushing it? Because we will see 18 does not have any next greater element here. That's what we are pushing into the stack. Now my eye is to this position. Now we are going to check the 6 is less than the element present in the stack. We have to push again into the stack because for the 7 we don't have any next greater element right now. Now in the same way my eye pointer will point to 5 and this top of the stack is greater than the element in the array. We have to push it again. Now you can see here if the element present in the stack, the top of the stack is less than the current element in the array which is 11. That means for 5 you found the next greater element. We will check whether this element is greater than the top element of the stack. What we have to do, we found our next greater element of the top element of the stack. We will just pop this element and put into the hash map and the top and the next greater element also. Now this will continue unless and until we will find lesser element in the stack. For example, you can check 6. 6 is also less than 11, means 6 for 6 we are getting next greater element as 11, which is 11. Now we are going to check for 7. We are getting the next greater element as 7. We will pop from the stack and put into the hash map as 11. Now we are going to check for the 18. 18 is not less than 11. That means we for 18 we can't check or we can't say 11 is the next greater element. So when the loop fails here, we have to push into the stack. Now again we have to iterate to the next element. For the next element we will see if the current element in the array is less than the top element in the stack. No, it is not. Then what we have to do, we will have to pop top element from the stack and push into the hash map and the next greater element. That means for 11 we are going to find next greater element which is 12. Now after that we are going to push the current element into the stack too, which is 12. But why we have pushed 12 here? Because we are not finding 12 as the next greater element of 18. So this is done, we are getting the base cases persisted in the hash map. What about those cases where the next greater element does not exist at all? So we have to run one more loop and we have to check whatever the stack elements are existed right now. We have to put into the hash map the null as a next greater element for it. For example, we have to run our loop until the stack is empty, then pop from the stack, so and put into the hash map with the next greater element as null, again pop from the stack, put into the hash map and next greater element as null. So in this way we are going to get our solution in the optimized way. So let's see the code. So this is the method signature where we are returning the hash map which contains element and the next greater element in the given array. So here we are initializing our hash map and the stack also. So stack is used for optimizing our solution. So we are running the loop from 0 to array length and we are checking if the stack is empty or the ith element in the array is less than the peak element of the stack, we are going to push into the stack that element, because we are not going to find the next greater element. That's why we are just pushing directly to the stack. What if we found the next greater element? So the condition is if the ith element in the array is greater than the peak element, that means we are going to pop that element and put the next greater element which is ARR of I, and we will continue unless and until we are getting the top element of the stack is less than the ith element in the array. So when the loop got failed, we are going to push that particular element so that we can check in the next iteration for the next greater element for this element. This loop will continue forever, and in the last, what we are doing this while loop is that it is checking unless and until the stack is not getting empty, there are left elements which for which next greater element are not obtained. So for those elements we are going to persist next greater element as null into the hash map, and here we are returning our hash map. So the overall time complexity of this algorithm is order of n, because we are using the linear time, we are working everything in the linear time, and the space complexity here is also order of n because of the stack we have used here. So that's all from my side. Subscribe to my channel to get more updates. Thank you. Have a nice day.